Alrighty, so let's do a do now that's a little bit more problem solving. Ida Livermore, sounds like a place, not a person, starts off on a pizza delivery route. She records her truck speed, which is what every single pizza delivery person does, which is miles per hour, at various numbers of seconds since she started. Alrighty, A. The truck's acceleration is the instantaneous rate of change of VT. Estimate the acceleration at 9, and because we're talking about hours, we're talking about 9 hours, and state units. Okay, the unit's gonna be miles per hour squared, because I'm gonna talk about that later. And then part B is saying, approximate how far did Ida's truck go between 1 and 9 hours. So, pause the video, try it out, and then we're gonna go over together. So since we're trying to estimate what the acceleration is at this point of the table, we're gonna have to, we're estimating, so it's just a rough estimate. We're gonna have to use the slope formula. Now some people get sometimes confused. Why don't you use 9.001 instead of using points around? When is it appropriate to use one method of estimating the derivative versus the other method? Now clearly, if we are using a delta x of 0.001, that's going to be a much better estimation of the derivative than using points that are so far away, like between here and here, that's 5, and between here and here, that is, I believe that's 7 miles per hour. So, I mean hours. So that's a big difference between that and 0.001. The only difference is, I don't know what the function is. I don't know how they get these numbers, what the function looks like. Now that's a problem. I could, because of my physics background, I can find the function, but you don't have that background. So you have no choice but to use this method right here. You're using a table, you're not using a function. Anyways, that cleared up. Let's find the slope. So the answer is going to be, after you actually do the slope formula, it's going to be 0.833, but it's going to be miles per hour squared. And the reason is the numerator of this fraction is going to be miles per hour. The unit for the denominator is hours. So if you divide miles per hour, or miles divided by hours, you're essentially going to get miles per hour squared. You pretty much have two hour units on the denominator. For the second part, it's asking approximate how far did Ida's truck go between 1 and 9 seconds. In this case, you want to find the area, or have an estimation what the area is. So the method that we're going to be using is trapezoidal rule, but you cannot use the trapezoidal shortcut, the one we covered, where you have like 1/2, and then the width, and first term, second term, 2 times, parenthesis, blah, blah, blah. You can't use that, and there's a simple reason for it. The table does not give a uniform distances between the x's. What I mean by that is, this is 1 away from each other, that is 3 away from each other, that right here is 5 away from each other, and that right here is 7 away from each other. I do see a pattern. It's clear that these are being squared, so that's 0 squared, 1 squared, 2 squared, 3 squared, and 4 squared. But still, the trapezoidal shortcut doesn't really work here. So we have to do something else. So we had to find individual areas of these trapezoids. So there was no shortcut we can use. So for instance, I should use a different highlighter. The area between these two regions is implied right here. I simply did 1/2 times the width. The width is the distance between these two numbers. Between 0 and 1, that's a distance of 1. And then I had to do the summation of the y values. And then for the next one, for this guy, I did the same process for this and this bad boy. So the difference between these two is 3, which is why I put a 3 right here. When you add them together, that's 15. That's why I put 15 right there. Difference here is 5. Addition is 25. Difference here is 7. The addition is 35. This was not a fun process. Oh, Mr. S loves doing math. I can't believe he's giving us all these problems to do. Well, I'm doing them too, all right? I'm doing them too. Anyways, We have the individual areas, and when you add them together, you have 210 miles. That's actually exactly what it turned out to be, and I know you know that I want 3 decimals, but I'm not going to write 210.000. That being said, let's move on. So that do now took a little bit longer than I wanted it to take, so that hopefully the rest of this video is going to be short. Students will understand and use the intermediate value theorem to find a value of x equals c in an interval a, b. So the intermediate value theorem pretty much says that, let's say f of x is continuous. That means there's no breakage, and that's important. We don't have sum like this. That is very important. So let's say f is continuous on the domain AB, between a and b, and y is some value between f of a and f of b. What that means is there has to be a value between a and b where y equals f of c. And what that means is, let's say we have like a function like this, right? And this is like x equals a, that's x equals b, that's f of a and f of b. I can't write anything correctly. What that means is, there's if you have like, let's say this value, let's call it like Mr. S, then there has to be a number, let's say student, between A and B. There has to be a value that, and I'm going to call that value that has to be, you know, that value I'm looking for, that, but it exists because this is continuous. There has to be a value between those two, where if I plug it into my function, I get Mr. S. That's all this theorem is saying. So if you have a continuous function, you have these 2 endpoints, and you have a y value, then there has to be, that's between the 2 endpoints. Then there has to be, when I say between the 2 endpoints, I mean like vertically. So there's a y value between f of a and f of b. Then there has to be a x value between a and b, where if you put that x value into the function, you get that in-between number. Anyways, let's move on. But Mr. S, Mr. S, Mr. S, why do we need to know this? Well, let's do an example, huh? So you have this function, and you're supposed to use the IVT to conclude that a value c occurs between 1 and 3, for which f of c is exactly equal 5. Okay, well, let's find out. Let's do this. First of all, is this continuous? Yes, it is. It's a polynomial. Polynomials are always continuous. There's no reason why it wouldn't be continuous. Therefore, it's continuous. Polynomials are continuous. If I ever ask you, is it continuous? And you say, yes, it is. It's polynomial. I will not be like, prove it, because it's just continuous. There's nothing that would make it break. So now what we got to do is we got to show that 5 is between 1 and 3, right? Because if you remember prior, those were the 2 vertical endpoints that I was talking about. There has to be a y between 1 and 3, where if you put in the x, you get that value. So what is f of 1 and what is f of 3? So f of 1 is 6, f of 3 is 4, and boom, 5 is in between there. So 5 is between 4 and 6, and because it's continuous, that implies that there's a number between 1 and 3 that will make your function equal 5. Now, it's not necessary for you to write everything like this person wrote down. F5 is in between f of 3 and f of 1. Therefore, by the intermediate value theorem, there exists a value x equals c such that c is between 1 and 3. Yeah, you don't, if you just say there's a value between 1 and 3 that makes it equal to 5 because of IVT, we're good. We are okay. So now, when you have to find the approximation, there's actually a purpose for it. You're going to know that the value exists. Now, this is a calculus class, so we get to break some rules and try stuff out. That's pretty cool. But my mind sometimes thinks we can estimate perfect ones, because the coefficients are 2 and 1. So you can get the possible roots and maybe find something between the possible roots, but you have a graphing calculator. So in this case, we pretty much created the function in the y. So it equals 0, which I'm going to keep in mind. And I just put in the graphing calculator what I see right here. X cubed minus 4x squared plus 2x plus 2. Then press the graph button, and that's what you will get. Now I kind of prepped it a little bit. And for my intermediate value theorem, I'm looking for a value between 1 and 3. I know it exists, and because of the IVT. And then I kind of messed with the y's a little bit to make it look nicer, which is why I have so much hair on my thumb. So when you press the trace button, where are you? Where are thou? Right here, right here. Look at that. Okay, press the trace button, and what it will do, it will actually follow the graph. Oh, wow, that's perfect. Alrighty, that was perfect. The value I'm looking at is, what is the x value when the y equals 0? Because I told you I keep in mind that y equals 0. So at 1.297 or 298, I have roughly 0.044. That's close enough. So the calculator will not always give you perfect zeros. Now, there is actually a place where you can actually do it. It can actually calculate the 0. You can press 0. And then you just do like the left bound, and then you do the right bound, and then guess, yes, please guess for me. And then it kind of gives you a better accurate number, right? But it just asks you to estimate it. So an estimation would be fine, you know? You don't have to go to these lengths. Now, since I already did it, I'm gonna go ahead and use this value. And that's it. Write down this value, and we're gonna move on. For problem 1 and 2, explain why the intermediate value theorem applies on the given closed interval, then find the approximation for the value of c and the corresponding open intervals for which f of c is exactly equal to the given y value. Illustrate by graph. Well, the thing is, this is pretty much a polynomial. If you were to use the binomial theorem or something like that, you can easily get a polynomial out of this. And we know polynomial is continuous. So 1 is continuous. Also, if you plug in the endpoints in there, you're going to end up with values that are around 8. You're going to get a value that's less than 8. You're going to get a value that's bigger than 8. So by using our IVT, we know that there's a number between a and b, between 1 and 4, where you're going to end up getting y equals 8. So you have to find that value. Oh. Here's the answer. You're probably wondering, Mr. S, what journeys have you taken to get to this answer? Let me tell you. I made this video 3 times. And the reason is, the first time, I pretty much wasn't aware that it said that it actually didn't want an estimate. I thought it wanted an estimate. The second time, I wasn't recording. I was talking to nobody. So let me go over what I did. So first of all, I put the function as the way it was. Exactly what it said is what I wanted. So I pretty much created my function. I went to the window setting, and I made sure that my x's are between 1 and 4. And I knew that negative 2 to the 4 is 16. So I knew it was going to alternate between 0 and 16. I made my graph, and then I estimated, because I thought I could estimate. I went to trace. And the reason why I estimate is because I'm pretty lazy. I'm not the most active person. So we have 8.318, which is pretty close to 8, and we have 7.811. I'm going to pick this one because that's closer to 8. So my estimate was 1.447, but it didn't say estimate, in which case I had to find the 0. Now, you clearly don't want to do 0 here because your function didn't equal to 0. So you go back to your little function. It equaled 8, so you want to subtract 8 now. So that is minus 6. And then when you go to window, you want to make adjustments here too. So subtract 8 here and subtract 8 here. Now, if you don't know why I chose these values for the windows, because your graph, I don't like guessing and then adjusting later. I like to think a little bit and be like, oh, what would be a good window? And what I usually do is I look at how the function will alternate, and then I make my changes. And since I subtracted 8, I subtracted 8 from my limits, for my function limits, the y ones. Anyways, I digress. So now we can actually find the exact value. You go to calculator, you press 0, and this is the second time I'm doing this. It starts to point so far to the right. There is only 1 0 between 1 and 4, but of course it's like left bound and right bound. Yeah, that's the 0 I'm talking about. So please get me an exact value. My estimation was pretty close. The answer is going to be 1.435. Please record this answer the same way I recorded this video 3 times. I'm not gonna lie, that was very frustrating what I just went through. Go away, video, go away. And what's gonna happen now? It wants me to do this in process again. It wants me to do it again. Well, first of all, is it even possible? So we're gonna see, is this thing continuous? Unfortunately, it is. So let's continue, let's move on. Does f of 0 and f of 6 bound -1? Please say no. All right, f of 0 is -8, and f of 6 is, it's a huge number, 6 to the 5th power. It's really big. Let's go ahead and plug it in. And of course they're gonna bound it. Of course this thing wants me to graph again. Now I chose to start the video right here. Actually, did you guys know that you guys can cancel functions like this? Like if you go to the equal sign and press X or enter, I was able to undo that function without having to delete it. Anyways, the reason why I want to start right here is because at this point, a lot of people might think that I want to put -8, but I do not put -8, and that's because my function is supposed to equal 0. And since I'm letting it actually equals -1, I want to add 1 on both sides so I can get it to equal 0. And when I add 1 on both sides, this becomes -7. No, not -7, -7. Alrighty, I hope that was clear why I made it -7 instead of -8. And then now you can put graph and then kind of mess with it a little bit, but I like to kind of mess with the window first. So that's between 0 and 6. And there's like no debating, we're gonna be closer to 6, right? And how does it scale? Well, if I put in 0, that becomes -8. So my lowest value is gonna be 8, and my biggest value is gonna be, let's say, 1. Really, it's gonna be 0, because I'm looking for 0. But doesn't matter. So let's graph this. There we go. And let's do the whole left bound, right bound thing. So second calculate 0. You're not gonna start close to the thing I'm looking for. Of course you're not. You are so slow at moving. I do. So left bound, I could have made the left bound way further left, but I didn't. And then guess it, and my answer is gonna be 5.875. And that concludes this video. Go ahead and draw the picture, write the answer, claim you used the graphing calculator, and we are done with this. I hope you guys kind of enjoyed it. I wanted to destroy 3 chairs today, but I digress. Have a good day.